Everybody. I have already interacted with most of you who have become part of this cohort. As part of the enrollment process, most of you have already interacted with me. Maybe like with few, I may not have directly interacted, but majority of the people I have already interacted. So you may already know about me. But just to give a brief about myself to start with. So I'm having an experience of 13 years in the overall IT industry. And last role which I used to do before starting this part, like the education part, was Vice President of Data Science in Motilal Oswal. That is one of a trading or brokerage company, I would say. Most of my experience has been in the BFSI or banking finance industry, majority in the stock market related area. Now, over this 13 years, some of the years, like 8 years, I worked into AI ML based systems. We deployed multiple AI ML based models in the production. And then the recent few years, we have been working on Gen AI, agentic AI, because that's what the trend has been. A lot of new things are happening in this space. So that's what we thought, okay, let's try to like, I've been taking a lot of interviews and interacting with people. One thing I feel is there's a lot of gaps in terms of the knowledge that is required for people to start implementing hosting the systems. AI agents as a term is being misused a lot in the internet, I would say. So AI agents as a term is good. This technology is very good, has a lot of power, but you can't use it everywhere. It's not like a one silver bullet that can be used for all these things. But the goal is like there are some specific use cases where it is very good, but it also has a lot of challenges. Implementing the systems is not that straightforward. There are different challenges which are available. So the goal that we have over this course is to help you understand where this AI agent, Gen AI based systems can be applied. On top of it, where the things cannot be applied. So that's our core goal. So the overall structure of this course, if you have already gone through this website, like we have overall like 10 to 11 weeks, which it will be, but 1 or 2 weeks, like it can go ahead. It will not be less, but mostly it will be going ahead 1 or 2 weeks. We have mostly kept it like limited students so that we can provide more one-to-one interactions to all the students rather than keeping big and where we are not able to focus on everyone. Okay, so overall like 60 hours, it could even go more than 60 hours. And with the platform that we have, our goal is to give more of hands-on experience. Okay, with our platform, we want to see that everyone get to code together with the mentors rather than they just keep watching or they do the things by themselves. Our goal is how do we make you hands-on with us? Okay, because majority of the people again that I do interview with, they know theory very well, but when it comes to the actual practicality of implementing things, they may not be that good. So that's where hands-on plays a very important role. Then some more key features that I would say is we are going to, yeah, more than this, there are some perks I would say. We are going to give you access to Azure OpenAI model credits. Okay, so you'll all have access to some good models which are being used by the whole industry. So this is one part. Small batches, as I said, we will have an integrated code editor that you will be able to see in some time. And these are some important parts. Now let's talk about what all things are there, like how is this course structured around? Okay, what kind of topics, what kind of things we are going to go around. I'll try to brief you on that part. Okay, so let's now discuss like what we are going to cover as part of this course. So this course, we are majorly going to focus on the recent advancements which have brought the in terms of the AI, and the majority of the part we are going to focus on how do we build the AI systems on top of the LLMs. Our goal would be to learn different aspects with respect to building the applications on LLM based systems. Okay, this ChatGPT based models or this Anthropic cloud based models. So all of these models which are available, which we call it as LLM models, we understand like how do we build some specialized AI applications on top of it. We started with like we added a fundamentals of Python as a separate module
Earlier, it was not in the plan, but we thought for everyone's benefit, we will be adding fundamentals of Python. Initially, it was not there, but the goal with this Python fundamentals would be it will be a 5 hours of around 5 hours of course, but we will be focusing on very important components as part of the Python. Okay, Python in itself is a very large, there are a lot of different pieces. If we try to cover Python separately, it could take around a month of time. So we will not go into that depth, but our goal would be to cover at least the fundamental layers. So people who are coming new with respect to the Python, they get to see the syntax, understand how this Python syntactically work. So this will be the goal with the 5 hours content. Then we go on to the basics of LLM. Again, now LLMs are a very complex entities internally. If we talk about how are they built, what kind of thing goes into building them, those all things requires a different aspect of learning, maths, fundamentals and statistics, calculus. On top of it, also how the machine learning systems work, how the deep learning based system works. So our goal will not be to get into the depth of the LLM, but this LLMs have opened up a, a good layer in terms of how people can use it. It has like democratized. The LLM usage is being democratized through the API based access, which we get through this multiple LLM. We can build some sophisticated applications on top of the LLM. We will understand what kind of inputs are required to LLM, what kind of outputs they provide. When you deal with ChatGPT, there are many things which you don't have access to tweak these models. But when we try to call them or when we try to build some applications on top of this API-based LLMs, we will have a lot more parameters to fine tune the outcomes from this LLM models. So we will focus on understanding some basics of LLM, which will be very useful for us in terms of building the application. So we will not go to a very depth, but understand them at a very high level thing. Then a core piece of any LLM-based application would be prompt engineering. We also call it a Gen AI. The previous year was more focused in terms of the Gen AI. We had a lot of applications with respect to the Gen AI. Even now, many of AI applications that you will hear about will be pure Gen AI internally. There'll not be much of agentic, and even if many people will tell you that okay, it's agentic, but I'll guarantee you that more than 60-70% of the applications will be pure prompt engineering and Gen AI. Okay, so we will go through understanding what is prompt engineering, what is Gen AI, what kind of thing goes into it. One thing I would like to say is prompt engineering is a programming language for LLMs. So whatever you want to get done from this LLM, you have to do it through the prompt engineering. Then we go to the next part, which is very important in the current Gen AI-based applications, is a RAG. Okay, so what is RAG? Retrieval Augmented Generation. So we will see what is it, why it's important, how to build it. We will go through the basics and advanced. RAG allows us to provide this LLM models with external knowledge. Okay, so LLMs are built with a specific knowledge, but to make them access an external knowledge base, we use this concept of RAG. So there are a lot of different concepts, terminologies in terms of the RAG, which we will go through. So there is some basics, and there are some again advanced concepts within that. There are different types of RAG applications. So we will go through those in this part. Then our focus would be to learn the AI agents. We will be learning it through different libraries. Prompt engineering, we will be learning through LangChain. Then AI agents, again, with AI agent, there are different frameworks. Our goal would be not to learn every framework, but just to start working with few frameworks. And once you understand what happens with some frameworks, you will be able to apply that same knowledge to multiple frameworks. You don't have to learn every single framework. Just if we our goal will be to learn the fundamentals. Once you learn the fundamentals, you will be able to apply these fundamentals to any framework. All the frameworks will have a only small changes. So your goal would just be to learn those small changes if you have to go with a new framework. So we'll focus on LangGraph at this stage. We'll also go through Creo AI, AutoGen, and some more frameworks if required. So learn what are AI agents and learning them through some from the scratch approach and also through the frameworks. Next would be some core components of this AI agents. So there are tools, memory, like how do we create a conversational applications? How do we make AI agents access some external tools? It could be your Gmail, it could be your Jira tickets, it could be your code, or it could be your local machine. How do we make this AI agent access the systems? That is the goal with the tools, and memory is more of creating a conversational systems where this AI agents will have a memory, where they remember what they talked with you before your current chat. Is there any kind of a history of chats, and it will be able to use those. Then multi-agents. This same agent, like how do we create a multiple agents, which as a complex piece can try to accomplish some more refined problem statements. Next would be the discussion around evaluations and guardrails. This AI agent, LLM-based applications, the GenAI-based applications, whatever we name it, all of these are very different from the traditional applications which we develop. Okay, I would not say traditional, but just the other type of software products which we develop, they're slightly different from that. In other software development approaches, when we create test cases, the goal would be for a one single input, the output should always be same. Okay, the goal there is one for one input, output should always be same. But with LLM based application, it doesn't happen. When you try to put the same prompt, output will always be different. Okay, output will always be different. So how do you create a good testing strategies? That will be part of the evaluations. Then we go through the guardrails. So guardrails is going to help us in terms of how do we limit someone from tampering with the LLM based applications. Okay, there are a lot of different hacking approaches. There are some ways by which if people get to know how your system is working, they can try to do some kind of a hacks, prompt injection and all. So we try to understand how do we guard them against those kind of attacks. After that, the goal would be like learning these individual pieces in a module by module way. At the end, the goal would be how do we try to create some end-to-end projects. Okay, from the start till the end, we try to put these pieces together and build some end-to-end use cases. So we'll go through 2 to 3 use cases where we will work through start to end and see how do we build the applications. Then at the end, many people have this confusions around, okay, this AI agents looks to be very different. Then how do we deploy them? What kind of strategies are used to deploy, maintain the CI/CD pipelines? So we will be going through the CI/CD based strategies. At the end, there is going to be capstone projects. Okay, so capstone will be you will be working on the end-to-end use case. Okay, you will be hands-on working on problem statement, strategization, implementation in a group-based projects where you will try to accomplish the end-to-end project, and we will be there to help you uh, complete those projects. So this is going to be the goal. One more piece is going to be the observability. Observability is more about how do we observe the systems? How do we monitor the system in terms of cost, in terms of latency, in terms of the input outputs, all of that, how do we observe? There are different observability tools. We will try to look through those tools and what kind of things to monitor. So that will be observability. So this is going to be what we will be covering over the 11 weeks. Okay, that will be the strategy, but it may go 1 or 2 weeks more also. That is possible. Now let's talk about what we are going to cover as part of the this first week. Okay, so as part of this first week, which is the fundamentals of Python, Python plays a very important role in terms of the development of AI ML based applications. Okay, before to Python, people used to mostly use R for ML based activities like 10 years back. After that, people saw like the whole community of Python started to build a lot of frameworks, okay, libraries, frameworks to deal with statistical, probabilistic, ML, deep learning based applications. And after that, the community has been going crazy. Like the whole community is doing very good efforts in terms of building some good frameworks, okay? And no other framework or programming language is able to get in. and get this kind of a community. There are many languages which came in like Julia and others, but that those communities were not able to sustain, whereas the Python community has grown so big, so they are just able to get anything new, transform it, and make it usable. So the whole community is just continuing with Python. On top of it, one of the features of Python is it comes up with support for all the platforms like with Windows, Linux, Macs for all of those. Also, it also provides an integration with the native languages. Okay, like C, Java. For C++, it comes up with a variant called as a Python. For Java-based integration, it comes up with this Jython. Okay, so many frameworks which are well known within the Python ecosystem are built in C++, but there is a top integration that is provided by Python. So you're doing a programming in Python, but underlying it is using C++. So because of this kind of integration, the community is still able to scale, whereas the underlying frameworks could be built in different languages, but you are still getting a Python as a layer. So as part of this 1 week's goal, we will be trying to cover the fundamentals. Okay, so within that fundamental, first thing would be variables. We'll understand the different data types which are supported by Python. Python provides, there is no data type you have to explicitly provide when you're defining the variables. Variables are through which we will be allowing users to store any kind of a data. These variables are nothing but names that we provide to any type of data, and this variable can store different type of data. So the basic data types which are allowed are int, float, string, and boolean. Integers, floating points with decimals. String would be a characters, and then the boolean would be true false kind of a scenarios. Then there are some advanced data types. So within the advanced data types, we have list, tuple, dictionary sets. These two things together, the basic data types and advanced data types, are a very important part of Python. Okay, most of Python is good in data analytics based applications and other automation based applications, but these data types which are internal to Python allows a good power to Python for all the different use cases. Then we will go to understand how do we build conditional statements within the Python. Okay, how do we create a branching? How do we define based on the different statuses? How can the program try to branch out to some different logics so that we will define through the conditional statements. If, else, else, these are some keywords which we'll be using in this. Then the loops through which we will be able to loop through multiple data or keep on running something till some conditions are occurred. So that is where for and while will come into picture. Then we go to define functions. Functions would be more of providing us an access to allow reusing a specific part of a code with a given name. So if there's a block of code that you want to repeat again and again, functions will allow us to define that code with a name as a variable, and then that block of code we can again just repeat with just that name. So functions becomes a very important part. Then we have error handling. So with respect to error handling, what happens is if there is an error in the program and if you don't handle it, the whole program may just exit and stop working. So we need a better ways to handle the errors. That's where try except and error handling would come into picture. And then during the program, we will also be required to call certain APIs. This APIs could be LLM based APIs or some different type of APIs to access certain tool, like maybe web browsing based APIs, search based APIs, database based APIs. So we may be required to call different type of APIs. So we will understand how we can call APIs from the Python code. That's where like API calling is one of a module, which we will also go through. Okay, so now let's get started with the platform in terms of the hands-on part. So now let's talk about the platform. So this platform, this is what you will have when you try to join any live session. So after the live session, this left-hand side, you will be able to see with the recording. So this platform we have built from the scratch to keep in mind of providing more hands-on focus to everyone. So we have this one part as a video conferencing tool like a Zoom, where this is being built from the scratch versus the right side is a code editor, which is more of a Jupyter style, Jupyter notebook style code editor. We call it Jupyter notebooks. They are more interactive in nature. Interactive means we will have this individual cells, and through the cells, we will be able to run the different code. So once we start a kernel, it will start one single session. Within that one single session, whatever variables we will create, whatever outcomes we will create, all of that will stay here. And also at each cell level, these are called as cell. Each cell level, we will also be able to see the outputs separately. So these are like more good in terms of debugging, and also in the development, debugging, visualizations, data analytics, all those cases, the Jupyter notebooks are good. So usually with Python, data science, machine learning, AI, generally we follow this Jupyter notebooks to do the development. At the end of the development, we try to transform this Jupyter notebooks into finally the PY files. This PY files will be finally used to run the code in the productions and other scenarios. So the whole development and the learning we will be able to do from this Jupyter notebooks. One of the thing is we will have access to every student's code in the backend. The mentor will have access to every student's code. If you face any kind of a issue, we will be able to see and guide you. You don't need to do share screening and other things. We will still have access to it. So if you face an issue, we will be able to help you with that. So one thing is we need to start the kernel. So this could take, once you start it for a day, it could take around some 30-40 seconds to start. So let's wait for some time. So once we have this kernel started, we will be able to execute the code. So this with this kernel basically means a session with respect to the code. So if I say a is equal to 100, a is a variable name, and I'm assigning 100 as a value to this variable, and then we say print a, this basically shows the value of a as 100. Again, if I try to access a in this cell also, we will get the access. So a is defined in one cell, but is also available in the other cell. So variables which we define in the cell will be available across the whole session till the time we don't restart it or we stop and start it. This whole session will be active. The code will always be here. It's not like if you stop it, the code will go away. The code will always be here. One more thing is you also see this numbers. So this numbers is a sequence of execution. Because what can happen in Jupyter notebooks is we can also go back and run this code. So now you see that this is 3, which means I executed this, and after that I came to this one. So we will be able to access and trace this execution logs. So if we try to restart, this will create a new session now, new kernel session. And if I try to do print A, now this will give me an error, and also the numbering that you will see will be from 1. To run the code, you can either click on this button. Okay, this button will help you run it. Also, on top of it, we have some shortcuts. So, in terms of the shortcuts, one is to run and be on that cell, we have a control enter. Okay, run and be on the same cell. Shift enter is one more thing which says that run and go to next cell. Okay, so if I do control enter now, what you see is my cursor is still on the same cell. But now I will do shift enter. You see that it got executed and moved on to the next cell. Okay, so sometimes when you have a sequence of cells and want to run it, we usually go shift enter, shift enter. But sometimes we just want to execute the current cell and don't want to go into the next cell. We use this. So usually, like we can run the code within this without using the mouse, also using this shortcuts. If you want to add a cell below, okay, we have control plus B, add cell below. Okay, control cell. So control B will, for example, when I do control B, this is our new cell will be created at the bottom. One more thing is within the live sessions or even after that, if you go to the mentor's code, you will be able to see the live mentor's code. Right now, you will be able to see this code to be saved, but during the live sessions and even after the session, if you come to this mentor's code option, you will be able to see the code which the mentor for that session has created. So even after the session, the whole code from the mentor would be available in this section. So right now, I'll keep it to this. We are not going to start the meeting. So we'll just stay on this part. I'll expand this thing and we will continue. So now let me say just I'll delete this cell. So you can just add, remove, delete, those kind of things we can do as part of this cells. So let's go ahead in terms of the content. I'll be just creating some blank cells at the bottom using control B. So first thing we will be talking about variables. Now variables are a way by which we will be creating like names to certain data. If like there will be a lot of dynamic data which will be flowing as part of any software program. And to access those dynamic data, we try to give them a name. For example, if you're going to have a customer and the customer is going to contain different data points like customer ID, customer name, lot of different information about the customer. And there are going to be different customers at different points. So to store those, we use variables. So variables are nothing but the names. Customer ID is equal to some type of a dynamic number. Customer name is equal to maybe my name. Okay, so and then we can also print it. So print helps us in terms of like printing the variables, printing the strings, printing like different things. So one would be variable, another would be string. These two things we will be usually printing. Any variable basically we can say, any type of data we can print as part of the print, any type of data. Now, when we define the variable, there are certain rules. So one is it should always start with alphabets. The variable should always start with alphabets and underscore. Okay, they can or underscore basically. So you will see the situations where we will have underscore and double underscore. We will not go into the detail. There are some rules around when it will have underscore and double underscore. But for now, let's just say they start with either alphabet or underscore. From the second characters, we can have the numbers plus alphabets, alphanumeric, and also underscore. Okay, again, as part of the internal, if you see, we can have underscore, but also I can put some numbers. So after the first character, which should be alphabet or underscore, it could be alphabet, numbers, and underscore. So this is some names, the rules which are there. There are again different rules in terms of uh, the way we try to define the variable name. So one would be like with underscores. Other people would use the camel case, which will be so camel case and with underscore. These are the two things. So camel case is usually we say customer ID rather than underscore. We try to capitalize the next uh, word in the variable, or you try to just separate it with the underscore. These are the two variants which you will see in terms of defining the variables. As compared to other languages, in Python, we don't have to define the data type for a variable. Data type will be inferred by the Python interpreter. Okay, data type will be inferred by Python interpreter. For example, there is a function called as a type, which takes the variable name as an input, and this will give us a type of the variable. Okay, in above case right now, let's say it is 123. 123 is not defined. We have not executed that. I'll just remove this just for clarity. Okay, so this is one. And if I also put this, you will see that this one is a string. Okay, so this one is string. So these are the type. Functions are functions are different things like print type. These are functions which takes input as part of this braces. Okay, so inside the braces, whenever you see this round brackets with some name you will usually have this as the functions. So functions take some input. So these are like input which we pass, and they'll come up with the output. So this is the output from the function. So this is one part. Now we have seen two different type of variables. Now in terms of, let's talk about the data types. Now this hash that I put, these are called as comments. Comments are a way by which we tell the program that, okay, these are not program, these are just some strings which are useful in terms of a description for the user, but don't execute them. So this, whenever I put a hash and write something, this will not be executed by the program. Okay, only things which are not starting with the hash will be executed. So in terms of data type, now we have int, float, strings, and bool. We saw that this is a int, this is a string. Let's talk about a float. Okay, so this is a float which contains a decimal value. Okay, we have a decimal points value, so these are called as a float. Again, if I check the type of transaction amount with paise, we see that this is called as a float because there is a decimal. If you remove the decimal, it will become again integer. Now, one more type is boolean, which is like, if you see, we can assign true or false. This can take two values, true or false. Both like T and F would be capital. Okay, so if we check again the type for this, we see that this is a Boolean. So these are like basic data types. Booleans are mostly used for situations where you only want like one type of output. Okay, you have just a binary situation, yes or no. So there we go with the binary. Also, this is also used in kind of conditional situations. We will have a multiple conditional checks in the program flow where we always try to check, okay, if the amount is greater than this, then do this. If the amount is less than this, then you do this. So this kind of conditional things also Boolean values really help. Strings are nothing but a sequence of characters, integers, and floating point data. So this is how we try to assign it to the variable name. And this variable then we can use to do different type of operations. Okay, we also have different operations in terms of this variables. We have arithmetic operators, which is add, add, subtract, multiply, divide. Okay, there is one more called as a modulus, which is used to get a remainder. Okay, so these are the different operators. So we can add and subtract together things like int float can be added and subtracted. Int float, all of this can be like the numeric data. Int and float, these numeric variables, we can apply this kind of arithmetic operator. Just for an example, I have a transaction, let's say we have a transaction amount, one is some number, and transaction amount two is some decimal number. And then we can do, I'll just show like two things, print addition, print subtraction. Okay, so this gives us the addition and subtraction. Again, this kind of things can be assigned to a variable. I'll just show. We can also, just for one, I will show addition equal to this, print addition. So output of this, we can assign it back to a variable, and then this variable can be used as a further thing. So in further program, we can use this variable to represent the addition of these two variables. So this is how the arithmetic operators really work in Python. So let's move on to the next thing. So the next very important thing in terms of Python is the strings. Now, strings are nothing but like, let me show you some examples. So strings can be defined. So this is like a customer name. We have a double quote and the string value. Account type, we have the single quote, some string value. Transaction ID, some single quote, string value. Address, string again with the three quotes. In Python, we can define the strings using this quotes. This character list of characters, we need to pass them as part of the quotes. We can't directly pass the string. We have to pass it as part of a code to signify the program that see this is a string. Okay. So string can be defined in three ways. One is with the double quote, other is with the single quote, and other is with the three quotes. With respect to double and single, there is not much of a difference. Only thing is when you're using double, inside you can also use single quote. Okay. This doesn't give you an error. With single quote, you can also use inside double quote. But let's say inside you try to use a single quote again, then this is a syntax error. This is not allowed. So inside the single quote, you can use double quote, that is fine. Okay, but the inside outside both should not be same. They should be different. Okay, so in this case, we are saying Arav Sharma with some single quote internally, saving account internally. This is a double quote, but that is just a difference. I'll remove this part. Let's keep it in the name part, and I'll remove from the below part. With respect to the triple quotes, what really happens is, so with triple quote, we have this multi-line strings. Okay, with single and double quote, we cannot have multi-line strings. For example, if I do this, this is again a syntax error. It says unterminated string literal, which is it is not terminated. It is still open. So here we cannot do it. But with triple quote, once you do it, you have this line spanning over multiple lines. Okay, this whole address, like this new lines are preserved. Even if you try to add some more spaces here, this will be preserved. So all of those will be preserved as part of the outcome. So just to show you this thing, let's say print, we go with customer name, print, count type, and then I'll print the address. Okay, so one is this. Okay, print account type. Account type is not defined as same. I think we didn't run this. Yeah, so if you see, first line is printing this customer name, this print. Second print is printing this account, saving account. This third print is trying to print this whole thing. If you see, there are the additional spaces which we added. So it is able to preserve all that extra string. So this is how like the strings like double quote, single quote, triple quote are available. Now, one more thing, let's say we want to create a, a bigger string by combining all these pieces. Okay, let's say we are like drafting a mail or drafting some kind of a message to this customer. And if you want to really do that, we can do it in one is like this concatenated way, which is a addition. We can merge multiple strings together by using a plus. Okay, there is no minus allowed, no multiply allowed. Multiply is there in some way, will not apply. But when we want to combine multiple strings, this is one of a way where we say this string plus this is also string type, then plus this string and then this string. Okay, so you see that my name is this customer and address is new line. We added a new line this. So new line is like a special character which signifies a new line printed to the new line. Now there is a one more way to do this in Python, okay, which is called as a f string. Okay, which is called as a f string. So within this string, we see that there is a f that is added, which says this is a formatted string. Okay, f string is a formatted string. I'll just add it here. Formatted string. So my name is this curly braces signify that okay, this is going to be a variable. Then address is address. This is again signifies that you have to put in this address as a outcome at this point. So when we print it again, same kind of output is expected. Same kind of a string is expected. So this is like how we can combine the string into bigger one. We can also assign it to a variable. Okay, I'll just show it in a different way slightly. Customer message. Okay, customer message, we can pass it to a variable and we can just print it, customer message. So we can also pass it as part of a variable. Okay, these are like, I'll just add it here. Yeah, just S missing. So this is one more way to define it. The strings are very important for us to learn because of LLMs and prompting, which we are going to do, is mostly through the string structures. The input prompt is going to be string. The output from the LLM is also going to be string. So majority of the work with respect to LLMs, we will be dealing with the string-based objects. Okay, so that's why understanding the strings plays a very important role. On top of it, this different data types comes up with their own functions. Okay, there are some functions which can be used to do some kind of a tempering, changes, modification uh, with these data types. Okay, example of certain functions, let me show you, would be something like this, where this is a customer name. Okay, and this comes up with this additional dot functions. So one is this dot split, dot lower, dot upper. If we run this, you will see that this is Arav Sharma original customer name. If I say dot split, and this is a function, and I'm giving that, okay, this is a space, it tries to create a list. Okay, this is a list type. We will talk about it after this. So this list is two different values. Now this is not one single value. This represents a two different values. Then this dot lower converts the whole string to completely lower. Dot upper transforms the whole string to complete upper. So these are some ways by which we are doing some transformations to this strings. These are just some of the functions. Okay, there are multiple different functions which are available with respect to strings. To check the whole list, we have this help function, again an object. So when I say function, you will always see that there is a function comes up with this round brackets, and then either we have some kind of an input or there is no input. In this case, there is no input directly. In this case, the input is this by what we want to split it. Just to check the whole thing, you can ignore this double underscore things. Usually, you can just come down. So this says that, okay, this is a method defined. And then there are the double underscore things which we can ignore. And if we come down to this, capitalize, basically it says capitalize the first character. Make the first character have a uppercase and the rest lowercase. This is capitalize. Case fold returns a version of the string suitable for caseless comparison. And center, this is more of a formatting, padding the data with more space. Counting. If you want to count a certain substring inside your data, then we can use the dot count function and provide an input. This thing gives us a description in terms of what is required as an input. Okay, this says that, okay, substring is required as an input. Start and end are optional. Encode ends with, if you want to compare some specific string, that whether your given string ends with something. Find certain thing, format, index. Is alphanumeric? Is the given string a combination of alphabets and number? For example, a PAN card. PAN card is a combination of alphabets and number. Is it only alphabet? Is your first name would only be alphabets? This does not consider space. This is only alphabets. ASCII characters. Is it only decimal numbers? So these are like, is it only lower? Is it all numeric? So these are like different type of functions which are available. It's a big list. We will not be able to cover all of it, but we will go through some of it. One suggestion, you just go through the list, read through the descriptions of each function. So at least you know that, okay, this is all is possible as part of the different options. Okay, some of the examples, let me show you. So this is the customer name, and then we have this dot count, a dot index a and dot index a after 4. So let me show you what does this mean. So one is, this is the original string. When we say count A, it tries to count this character A, how many times it is coming. This doesn't have to be single character. It could also be a combination of characters or one single string. Then index. Index gives us a location. Now location, Python is a zero index based programming language. So indexes are usually represented. Index is nothing but um, the place of certain character. So it always starts with the zero. So in this case, this is zero and this is one. So this is a small character. If so, this is actually matching the case also. That's why it is going to this. So you'll see that zero and one. Okay. If now A is multiple times coming, if I don't want this one, I want to look from this side. I can also give it index that we can only look after the fourth character. Okay, or fourth would be in this case like zero index, so it will be fifth character. Let me just change it. Okay, now if I change it to maybe RA, okay, and then if this I try to transform to HA, what you will see is HA is coming one time. Okay, sorry, RA is coming count is one time. It just says RA is coming one time now. HA is coming at eighth location. So let's count 0, 1, 2, 3, 4. The space is also counted. So 5. This is also counted 6, 7, and this will be 8. So that's why it says eighth character. So we are starting from 0. So this is basically start counting after 4. So 0, 1, 2, 3, 4. So it is only going to start looking for A from 4 and it found A at ninth location. So this is how this function can help us make certain decisions. That if user is, let's say, giving us a prompt, some prompt is coming in as an input from the user, and you want to validate that, okay, this kind of thing is present in the prompt or not. Is he talking about some kind of a customer ID? Is he talking about some kind of a product? Is he talking about some kind of a complaint? So if you want to compare, we can use this function to validate those kind of things. If you want to check a documentation for only like specific function, you can do help object name dot index. This will give you the description only for a specific function rather than the whole function. If sometimes you're confused and you just want to know the whole syntax of certain function, you can always look through this. Okay, so now you all can try this thing. Go through the help of string and try to use this below set of functions on the given string. So one is index. Use the dot index to find out the location of slash. Okay, location of slash. Count this slash. Okay, how many counts do you get with respect to the slash? Then again, split this whole string by the slash. Check if the string is an alphanumeric and check if the string is only alpha. Now this does not require any kind of argument. So try with this experiment, pause the video, try this thing first, and then you again continue on the video. Okay, so pause and try. Okay, if you face an issue while running through this anytime, just let me, you can message me and we'll always be there to help you try it out. But try it by yourself first. Now let's talk about the advanced data type. So now in terms of advanced data types, we have list, tuple, dictionary, and sets. Okay. So in terms of this list, tuple, dictionary, and set, okay. So now within the list and tuple, there are two different type of objects. One is a mutable and immutable. We can like categorize this into two different types. So one is immutable and mutable. So what mutable means is once you define the object, okay, within this object, like these advanced data types are not just one variable, but a combination of different data points. Even within the same variable, we will have a different data points. We will see how. So once we define this, you will not be you with mutable, we can make changes. Changes are allowed on the elements. Okay, the individual elements which will be there, the changes will be allowed. And in other situations, the changes are not allowed. So we will see the mutable versus immutable data types. So first, let's start with the list. So list allows mutable data points. Okay, list is a mutable data point. So within mutable data point, so let's see with an example. So one thing, list is like a very versatile data type. Okay, and highly used data type as part of the advanced data types which we discussed. List is the one which is most popularly used. So within the list, it starts with a curly braces. Again, a variable name. We have this, sorry, this is a square bracket. So it starts and ends with a square bracket. And within that, we have a different values. Now there is no limit in terms of what kind of data type these values can take. As part of list, the data types can be completely dynamic. You can have a mix of float, boolean, string, even a list of lists. So those are complex pieces, but you can have a combination of different type of values. So even here we see that there is a float and there is also integer value. Okay. So let me also print the type. So what you see that is a list, and so these two things we are defining. So we are trying to print. So this is like a print. So first thing is transaction amount. This is the list, and this is basically a type which says this is a list. Now on top of it, we can also access the individual values, which is called as a indexing. Okay, this is called as a indexing, where if we want to access those individual values internally, we can do that by using indexing. So indexing is usually again followed through transaction amounts zero. So it's a zero indexing structure. That's why we see the zero, but we can access any value by specifying the index. Okay, so this is how we can specify the index. Now, if you want to check like, okay, there are how many values present overall, so we can do print transaction amounts. Okay, just a length is a function. So from this function, we get to see that there are total 8 elements as part of this list. Okay, there are total 8 elements as part of this list. So this indexing, if we try to go beyond or even at 8, see, total 8 elements are there, total 8 elements. But as part of a zero indexing, you can only pick up values till 7. If you try to go for 8, you will get an error which says list index out of range. Okay, so you can only pick up the values till 7, which will be the last value in this case. So using length, we can identify what is the how many elements are present in this. As part of a further indexing, one is like based on the zero indexing, which starts from the first element. But let's say I want to go from the last element. I want to say that, okay, give me a last element. So then we can use a negative indexing. Okay, so the negative indexing goes like this with minus. If I say -1, this will give me the last value. So if you see in this case, like 7 versus -1, both have a same thing. I'll just change it to 0. So 0 will give us the first value and -1 will give us a last value. So here it is not a zero based minus indexing. Minus indexing always starts with the -1. Okay, it starts with the 1. Let's say I just take it and try to pick up -4. This will give me the fourth value from the backside. 1, 2, 3, 4. Okay, so this is what you see in the fourth. The next part is called as a slicing. Now, one is you pick only one value from the list. But what if you want to get a subset of the list from the data? Okay, now if you want to get a subset of the list from the data, we need to use the slicing functionality. So slicing goes with this thing, that list variable. We have a start index, end index, and there is a step. So we have to specify that start from this value and go till this value. And step I will again define in some time. Start goes with the zero-based indexing, and whatever you specify will be excluded. Okay, let's see one example and I'll make it more clear. So we say, okay, start from 1. Now 1 means a second value. Please remember that. And end at 4. But when we say 4, it does not go till the 4. So the indexing is only 1, 2, 3. Fourth is excluded. Okay, 1, 2, 3. That's why we say end index is always excluded. Okay, so then we have this next is a step. So step is usually used when we want to get, let's say, we want to skip in between values. Okay, we want to only get even numbers. We only want to get odd numbers. Then we can go with the step. For example, now let's say from 1 to 4, I only want to get the even numbers. So then what we can do is we can say colon 2. By default, it is 1, but with saying colon 2, what you will see is this 324 got skipped. Okay, and it directly jumped to the next one. It got skipped the 324 and it directly jumped to the next one. If I increase it to, let's say, 6, okay, this also to the 6. Now we'll see that 323, so this value, this got skipped, we got this value, this got skipped, and we got to this value. If I skip to this through 3, this is what is happening. So next, this value, the start, end, and step, at least one of it should be there. Okay, out of this 3, at least one of it should be there, but some of it you can skip it. By default, the last one is anyway would be by default 1. Even if you skip it, it will be considered as 1. If you specify, it will be taken. But if we say that I want to start from the 4th element, but want to go till the end, I can skip it. Okay, so this will start from the 4th element and will go till the end of it. In the same way, if we want to say just uh, like start from the 1st, but go till the 3rd or even like 4th. Okay, so you'll see that this element is coming here. So this is like the started skip. We say that, okay, start from the complete beginning, but only go till the 4th. So you don't have to specify 0 or you don't have to specify anything here. Just one more option is we can even say okay, so this basically says completely from the start till the end, but the step of 2. So you're always going to pick up the even numbers from the data, but the whole data is being considered. So this is how the slicing, we can tweak this data for the slicing. Okay, start, end, and the step, we can play with this. Now, if you look at the help of list, if you look at the help of list, you will find different type of functions which are possible. We'll skip this double underscore. We see that there is an append, which with which we can add new element to the list. We can create a copy of the existing one and store it to a new variable. We can do a count. We can find out the count of specific, like the way we did it in string. Here also we can do the count. Add one list to the other one, create a bigger list. Find out the index of certain element. Add certain value at a specific location. Pop is to remove the value in a specific index and get you that value. With remove, you provide a value that you want to remove. Reverse, sort, all of these are like different type of functions which are available as part of the list. Let's try out some of this functions. Okay, some of these functions we can try. For example, one is the append. So if we try to do append, this existing list would be changed. What you see is earlier the list was only till this point, but now after adding this 345, now this is getting added as part of this list. Similarly, we can also call the remove. Okay, let me again print it after the remove. So we will be able to see that now the 345 is not there. It is removed. One more variant is a pop. So pop usually returns the value. So whenever I say return, return is something that you can capture in certain variable. So I say that from the third index, give me that value and also remove it from the existing one. With this remove, you do not get this value. But this one, you say that, okay, give me the value from the third and also remove it from the transaction amounts. So we can store it. Okay, amount equal to. So if I try to print them like comma separated, what you will see is from the third location, which is 0, 1, 2, 3, this value is now captured as part of amount variable. And then this is your transaction amount. Okay, now where this value is not available, which we removed. So now let's talk about how do we make modifications to the individual elements from the list. Okay, if we want to make changes to a certain element in a certain location, we can do that by following this kind of a structure. Okay, where we have this list variable, this is the index, and then we can specify, okay, this is what we want to assign to the given index. Okay, so this is how we can make the changes. And if we check after assigning this, just before that, if you see the third index, right, 0, 1, 2, 3. So this is the third index value right now. And if you run this, we see that this third index with 234.23 is removed and it will have this new value. So this is how like we can make changes to any element. So add, remove, delete, change, all of it is possible. Again, covering all the functions with the list would not be feasible within this session. So you guys can go through the whole list and just read through the description of each function so you at least know what all things are possible, even with lists. Now, let's go toward the tuple. Okay. Now, tuples are defined with the round braces. Okay. Earlier, the list was defined with the square bracket. Now here we define it with the round bracket. Now this example which we have took with the tuple, again same structure, the list of the sequence of values with comma separated, but we are trying to add it as a round bracket surrounding it, which gives it a tuple nature. Now tuple are immutable in nature. So when I say immutable, I mentioned to you earlier that immutable objects, this individual elements once defined, we cannot change. This is like static. This is like constant. Once we define it, we will not be able to change. Similarly, if you think of the list, we will be able to change the internal values. But here, if I try to say that, okay, change a value to Wednesday, this will give me an error saying tuple object does not support item assignment. Okay, it does not support any new assignment, addition, deletion, all those things are not supported as part of tuple. The tuples are usually used to define something which you think would be constant, okay, which you don't want anyone to change. See, usually in bigger projects, it's not just only one person who works on a project. There'll be many people who will work on the project. There'll be these variables which will be passed across different people, different modules. And when one person is implementing something, he's saying that, okay, this is a constant. No one should be able to make any changes to this. So by defining a tuple, we signify that, okay, you should not make a change. This is supposed to be fixed in nature. Okay, so this is how the tuples work. So if we try to look at the help of tuple, one thing we will see is there are only two functions. because it doesn't allow a lot of features. Its nature is just to store some constant kind of things which should not be allowed to be changed. So usually the memory requirements and the speed with which you can access the elements and all is much faster with tuple. Okay, with tuple, if you want to search any specific element, it is very fast as compared to list. With tuple, it is very fast because they're stored in consecutive level in memory as compared to list, which are like segregated in the memory in different places. With tuple, it is all consecutive in memory, and the search is much faster. If you want something to be searched much faster, you can go with the tuple. Okay, so these are some benefits with respect to the tuple. We can run these functions. Okay, count Monday, we get to see that count of Monday is 1. If I ask for the index, it will say that it is starting at 0. So as I said, like we usually call it O1. Uh, Tuple has a search capability of O1, which is like it can just search the whole tuple in a much faster way. So this is with respect to the tuples. Tuple also goes with same level of indexing and the slicing. You can use the same structure of indexing slicing also with the tuple, it works out. Now, if you again come back to strings, strings are also immutable in nature. They are inherently a sequence of characters. Okay, we have a customer name, and if we say from 0 to 5, we can do all the indexing slicing also with respect to the strings. So strings are nothing but a list of characters. So when we specify these indexes, this is like counting the character level indexes. But if we try to make a change to certain character, it doesn't allow that. It again gives the same error that str object does not support item assignment. So usually strings provide lot of different function, but it never makes change on that same variable. It always returns a new updated variable. The function that we have with the strings, they will never make a change with directly that same object, but rather they will return something which we can store in a new value. But they inherently doesn't support any kind of a changes. With list, when we did a dot append, one thing you must have observed is after the dot append, the existing object was modified. Okay, existing object itself was modified, but that doesn't happen with strings. It always comes up with the new value. So strings are also immutable in nature. Let's talk about the next object, which is a dictionary object. Now, dictionaries, in terms of a templatized way, if I have to say, the template of dictionary, variable name equal to, they start with this curly braces. And the structure is there is a key and a value. Okay, just to show you more refined example for this. So dictionaries are used to store something like this. It's like a normal dictionary where you have a key, and for that key you also have some description, right? So every key or every word has its a description. So that's a dictionary. In the same way, we have a key and a value. So this is used to store some complex data types where you also want the name of that key to be present. Okay, so this is like a customer's data. So in a customer profile, we want to store multiple details about the customer, and all of that we want to name it as a one single dictionary rather than storing those all as a separate variable. All of this is becoming a one single variable, part of a one single variable. Just few rules. The keys could only be strings or integers. Okay, keys in this. So this is a key, this is a value, comma, this is the key, this is a value. So keys can only be strings or integers, whereas values could be any Python object. Okay, any Python object. It could be again a list, again a dictionary, again a tuple. So value could be anything in the dictionaries. The indexing with respect to the dictionaries is not same as the tuples, list, and strings. Here, the keys are directly used to do the indexing. Okay, we can directly use the key value. There is no 0, 1, 2, 3 that works here. We directly pass this key values to do the indexing. Okay, so usually in list and tuple, there is a sequence that is followed. But with dictionary, there is no sequence because these are just key. They can come in any sequence. So the sequence is not important. It's just the keys which are available, which are more important with respect to the dictionary. Dictionary comes up with certain type of functions. Okay, for example, we can say dot keys. So we get a list of all the keys. Dot values, we get list of all the values. Dot items, we get a list of tuples which contains key value. Okay, so if you see this is a list with the square bracket. Internally, every item or a key value pair is given as a tuple. Okay, so this is a tuples being internally present, and then at the external level we have a list. So this, as we keep learning more about Python loops, conditions, and everything, these kind of things we'll be able to use in a much better way. Okay, and one more thing is the dictionaries are very identical to JSONs, JSON structures. So they are very identical. We can just transform this dictionary to a JSON and a JSON to a dictionary anytime. Okay, we can do a direct transformation. We will see it over the future, but a direct transformation with this is possible. Okay, now if you look at the help of the dictionary, it's always good to see this to understand what all functionalities are provided. You'll see that clear the whole thing, copy, get. So the get we will see, I'll show you get. Items is something we saw, keys. Pop will be similar to the way we saw in list, where we can specify the key. It will give the value. So if it says that remove the specified key and return the corresponding value. So return means we can store it. Okay. So pop item, it will be a pair of two tuple. When we say pop item, it will be a key value combo which will be returned. Set default, update, value. So these are like different type of functions. So let me show you some of the functions which are present as part of the dictionary. So one is the get. Okay, so one thing we saw is to access the values, we have this. Okay, so age, if I try to access which is not available, I get an error when we go with this indexing based approach. But there will be situations where, let's say, you're storing product details in the dictionary. And when you store product details, it happens that certain products may have some key and certain products may not have that key. And you need a better way to access these keys. So there is a function to access this that is called as a get function. Okay, so if we access the get, we see that it will not give an error, but it just gives us a blank value. Okay, it will just give us a blank value. But with the get, if I specify something that is already available, like name, I'll get the data. But if I provide something which is not available, it will give me blank. But there will be situations where I also want, rather than getting a blank or null, give me some default value. So if age is not present and I want always to get 18, I'll say that if age is available, fetch that. If age is not available, give me 18. Okay, if age is available, fetch that. If it is not available, then you give me 18. So this is a get with a default value. Dictionaries are mutable. Okay, so when we say mutable, there are we can make changes to the existing elements as part of the dictionary. So one thing is if we say name and then we say Arav Kapoor, we will see that the name would be modified. Okay, name is now Arav Kapoor. One more thing, to add a new element, we can directly do age. Age is not available. So let's say we add age as 25. We can also create a new key. So this age key is getting created. So we can remove the key using the pop. We can modify the keys we can add the keys. So all that is possible with the dictionary objects. Okay, so as part of a class, one more interesting question which was used is how do we create a multiple customers in this case? So to create a multiple customer, one structure that we can use is this. As I said, like list can store any type of data. It would be any type of sequence of data. So in this case, this is a list of dictionaries. Okay. This is like individual customer. This is your customer one. This is your customer two. This is your customer three. And it's your list of customer dictionaries. So if we check the type of customers, we will see this as a list. But if we check the type of customers zero, okay, now this is like picking an individual element. We see that this is a dictionary. If I want to only fetch a certain customer, I will say zero, and this will give me a specific customer. But if I want to get certain data from that customer, I can do customers zero name. Okay, I think name is not there. There is only customer ID. You see that we are able to access the customer ID. Let me print it separately. Okay, so this is how you see that we can just fetch individually. We will talk about loops later on. So using loop also, we will be able to go through each customer and do some operations if required. So that is again something we will see over the next session. Okay, so this is more of the dictionary. Okay, we can also assign this into individual variables and then assignment, and we can access their data. For example, we can say customer one equal to this. And if you look at customer one, we will be able to access the data in this format. Okay. So next, let's talk about set. So to define the set, let me show you one example. Okay, let's say these are two different groups. Let's say in a company, there are two different games which are being played and employees are participating. These names are nothing but names of the employee. Group one is a list of people who played in game one. Group two are the list of people who played in game two. In game one, it is possible that same person played multiple times. In game two, it's possible people who played in game one also played in game two. So there is an overlap also possible. There is also repetition possible. Sets allows us to get a unique transformation from all the repetitive data. Okay, if there is a repetitive data, sets just tries to transform it all into a unique list of data. In this case, the name tree was repeating, and if you see name tree is only coming one time. Okay, so this is one feature where sets only store the unique data. Second is the name set is coming. You may have learned about sets in the school and college where it is about the Venn diagrams. If you remember the Venn diagrams where we have like the circles with overlaps, with intersections, with differences, with unions. Same thing we can also do with the sets here. Okay, so we can say group one intersection group two. We find out that okay, who are the common people who were both present in group one and group two. We can do union. We can take like all the unique values like from both the groups together. We can also take a difference from like group one, remove the people who also went into group two, who are the people who are unique to group one, who didn't go to the other group. So sets helps us in data analytics, some kind of analytics with multiple groups. When we have multiple group things, we can just compare them, validate them. So they have a very specific type of use cases. Okay, it may not be used in a lot of general use cases, but sets comes into picture with some specific use cases where we have these different groups, we want to check, validate, or we just want to transform a repetitive set of data into a unique set of data. For example, if let's say uh, from a system, we get a list of multiple values where there is a possibility of repetitions. Okay, this is a list. Okay, this is a list. Now let's say we want to transform it to a unique set of values. Again, back to a list, but a unique set of list. What we can do is Python, this objects of list, tuple, set, dictionary, there are these objects. These objects we can use to transform one object to another object. Okay, so first thing would be, let's say we transform this to a set by doing this. Okay, so now you see that this is transformed into curly braces. One thing, curly braces are also being used in dictionary and also being used in this. Only difference is curly braces with set do not have key value pairs, and set curly braces in set do not have key value pairs. In dictionary, they have a key value pair. That is the main difference. I'll try to take it as the set of names. So this becomes a new set with the unique names, and we can then transform it back into the list. And if we look at the unique names, now this is a list with only unique values. Okay, so this is how we can use the sets. One is to get like the repetitions removed, even with like a bigger subset of numbers data. And then second is to do this interaction, intersection, union, difference related activities. Okay, so there is a limited use, but in some use cases in comparisons and all, it plays a very important role. Great. So that's it for the today's session. But as a hands-on experiment and as a homework, I want to I want you all to work through this use case. Okay, so you have to create and manage a new customer mutual fund portfolio. Okay, so within this, your first goal would be to create a dictionary named new portfolio where the customer's name is going to be this Priya Singh. To this, you can also add more keys like this customer will have a customer ID, risk profile, and funds assigned. Okay, so this would be a list of funds. Then the customer wants to add a new fund. So how do you add a new fund to the existing defined dictionary? It's not like you have to define a new dictionary, but to that existing dictionary, how do you try to add within the existing elements a new element? Then you have to also update the risk profile from moderate to aggressive. And then finally print the outcome. So this is the structure. So follow this. If you face any queries, you can always message in the group or directly to me. Okay, so that's it for the guy. That's it for today. Thank you so much.